All right, everybody, let's get started. Hope you're excited for what's the last talk of day one. I'm Mark Stemm, and we're going to talk about how to use Kubernetes Audit Logs to secure your cluster. So a little bit about me. I work at Sysdig. I'm a senior software engineer there. I'm also one of the maintainers on Falco, which is our open source security product. And there's my GitHub. All right, so what we're going to do to start off with, let's talk a little bit about Kubernetes Audit Events and Audit Support. So if you don't know anything about it, it was a new feature added in version 1.11, and then it was updated with more features in 1.13. And what it does is provides a chronological set of records that document all the changes to your cluster. And it does that by adding auditing at the Kubernetes API server. Because almost all the actions that you do when you're administering your cluster go through the API server, it's a natural place to add auditing to document all the changes and see what's going on. Each audit event is a little JSON object that describes what they did, what the result was, and who they are, and all that kind of stuff. Here's an example audit event. I've trimmed it a little bit because there's a whole lot of stuff in there, but I kept all the interesting bits. So you can see it's just a JSON object, and it's got stuff like the timestamp of when the person did their operation, what action they were taking. That's the verb, because it's all like RESTful APIs. It's very straightforward to translate the HTTP verbs into the verbs in the audit event. You can see what URL they're accessing, which is often the resource that they're grabbing. In cases where you're doing something specifically to a referred object, that will be in the audit event as well. In this case, somebody's trying to do a delete of a namespace. So the object reference is in there, and you can say like, hey, it's the resource's namespaces, and then here's the specific namespace that they're acting on. You can see user information. In this case, it was Minikube. You can see RBAC information, so you can see what the result of the authorization decision was. And you can see like the HTTP response code and that kind of stuff. So it's a really rich source of information about what's going on for each of these events. So just, I wanted to give a preview of like some of the, all the stuff that you can kind of get out of these audit logs. It's a pretty rich source of information. So just some examples of the stuff you can get is, obviously all of the changes to your cluster. So anytime anybody creates or destroys or modifies any resource, you're going to see that in the audit log. Some more specific things is, you may not know this, but if you try to exec into a pod, you're actually going to see that in the audit log because the attempt to exec goes through the API server. If you don't know, it's actually a get where the resource is pod/exec. So you'll see that in the audit log as well. And a whole bunch of RBAC stuff too. If you're creating roles to define access about what things are allowed to do, if you create service accounts, if you create role bindings to link the service accounts and the roles together, you're going to see all of that stuff in the audit log as well. So it's a great way to see what's going on. And also you can see viewing stuff. So every time you write kubectl get pods, that's basically a GET request on the resource pods, and you're going to see that in the audit log. All of the above includes both actions by individual users, so me typing Minikube or you using kubectl to manage your production cluster, but it also includes internal Kubernetes services. So for example, when you create a namespace, it'll usually create a service account that's working with that namespace, and you'll see that in the audit log, even though you didn't create the service account. It was actually something like kubescheduler creating the service account. So you'll see that as well. Now let's talk a little bit about how you actually enable and work with audit logging. So there's a couple big pieces. The first is the audit policy. That controls what events go in the audit stream. So in there, when you define one of these audit policies, it's basically just a YAML file that has a list of rules. And all of the audit events that are coming out of the API server get matched against those set of rules. And if it finds a match between the rule and the event goes in the audit log. So you can do things there saying, I only want to see the things that relate to pods, or I only want to see the deletes of anything. So the audit policy is your first step towards filtering out the audit events to show you the stuff you want to see. The other piece is the audit backend, and that basically controls where the audit events go. You have a couple choices. It can go to log files, So, just some log on the same machine where the API server is running. And you can also go to webhooks. You can configure saying, hey, when you get a bunch of audit events, go do an HTTP post to this URI, and then somebody else will take care of it from there. And that's all in 1.11. In 1.13, one thing they added was this notion of dynamic audit backends. So there, it's a little bit like the webbook and the audit policy combined, but the important thing is that it's a Kubernetes resource, so you can create it and delete it and act on it like you can with any other resource. And we'll talk a little bit more about that in a second. So now let's talk about what goes in the audit log for each of these backends. So when you set up a log backend, it's just one line per JSON record and one record per audit event. So it's just the JSON object that we saw before, just one line at a time. So pretty simple. You have controls to basically say like where the log file goes, how to rotate it. You can do rotation based on size or age or anything like that stuff. When you set up a webhook backend, what happens is it does a little bit of batching. So it'll take a small number of events, turn it into a little chunk, make a JSON array out of it, and then post it off to your webhook. Again, you have controls for the locations. You can say like what host name and so forth to send it to. And then some controls about how the batching actually happens. You can say like, oh, wait 500 milliseconds before sending me some events, or wait 5 seconds before sending me some events. And also some controls about, like, there's some like rate limiting and other kinds of stuff that you can do when you're setting up the webhook backend. When you set up the dynamic backend, it's kind of a combination of these things. But the important thing is that it's, like I said, it's managed like any other Kubernetes resource. So you make an object out of it using something called an audit sync, and then you can create and view and modify those, just like other resources. So the process for enabling audit logging is a little different between 1.11 and 1.13. In 1.11, a lot of these components are static. So they're generally like arguments to the API server, command line arguments. So you'll see a command line argument. This is -- audit webhook config file, and then you'll name a file, and then that's where you're going to specify where the webhook goes. Same thing for like the log path and where the audit policy is located. Because it's all in the command line, you generally have to restart the API server if you ever want to change one of these things. So it's not as flexible as the mechanism that you'll find in 1.13. And it's also a little hard to see what any of these contents are unless you can get onto the API server. And so for like managed Kubernetes environments, you're not going to be able to see that stuff at all. Or they're going to have a different visibility way to show it to you. In 1.13, they cleaned up a lot of that stuff. So now it's just these audit sync objects that like I said, you create them as resources and can act on like anything else. You generally have to be a cluster admin to do it. But the nice thing is you can create multiple of them. So you can create one audit sync that has a policy and a destination, and then you can create another audit sync that has a different policy and maybe a different destination. And you can create them in parallel, and then the audit events will go to both locations. Generally, it's a much more operator-friendly way to deal with this stuff. OK, so now hopefully you know what audit events are. Now let's talk about how you're going to get data out of them and make sense out of what's in the audit log. Okay? So there's 2 ways to do it. There's the hard way and the easy way. I'm a Falco engineer, so as a little hint, the easy way is going to involve Falco. But first we'll do the hard way. So a really handy program that you can use for this is called JQ. If you haven't used it, it's kind of a streaming JSON processor. What happens is it reads JSON objects from standard input, does some transformations and filtering and so forth, and then just writes JSON objects to standard output, or strings or something like that. So it's a really handy way to act on these audit logs to extract specific information out of it. Just some examples of what you can do with JQ. So you can do selection. So given this input object, show me the value of the property called key, and it'll print out some value. If you want to do filtering, you can get an array of objects and say, hey, only give me the objects where the value of key is v1, and it'll just give you that object. You can also do transformations. You can say, hey, take this object and then output a string that's a mix of like plain text and the value of the property called key from the input object. And it'll print out an output string. Okay, so once we have JQ, we can basically build up a bunch of filters that work on the log file to extract interesting information out of the audit stream. So here's just some examples of what you can do using JQ. The first example is, let's say I want to find out anytime somebody creates a namespace. So the first line is what we're going to do the selecting on. We're going to say, show me the objects where the value of the verb property in the object is create. And then where, this is like a nested search, where object_ref.resource is namespaces. So somebody's doing a create, and they're doing it to a namespace. The namespace is resource. When I do that, the string I want you to print out is the second line. So it's just a plain text string, but hey, take the timestamp, put some brackets around it, so it makes it look a little bit more like a log, and then print out this string saying namespace was created, and then get object_ref.name out of it. Okay? Deleting a namespace is very similar, but all we're doing is changing what the verb is from create to delete. This third one's a little bit more fun, where we're basically saying like, hey, show me the cases where somebody creates a config map and they're really dummies and they put in their AWS private key in the config map. Don't do that. Use secrets instead. But if you did do that, this would be the way you could look for it. So the first line is very similar. It's saying, hey, show me the objects where somebody's doing a create and the resource that they're doing is config maps. And then the second line is kind of a filter saying, hey, when I take the request object and I convert it to a string and then I search in the string, do I see AWS access key ID? If I see that, then here's the string I want to print out. Again, it's the timestamp and then a message saying, hey, somebody created this config map and here's the full contents of the config map so you can see exactly what they did wrong. I didn't write just these three. I wrote a whole bunch of different ones, and you can find them all on GitHub. It's a little gist there. It's just called JQ filters for Kubernetes Audit Events. And I think I got like 20 there that look for different use cases. So go to town with that. OK, so that's the hard way. If you love JQ, stick with JQ. But if you love Falco, and you should use Falco. And if you don't know what Falco is, I'm going to make you love Falco. So Falco's a recent CNCF project. Sysdig had owned it for a while, and we basically moved it over to the CNCF. And it's basically a runtime activity monitor. What it does is accepts events of various types, and then it matches the events against a bunch of rules to look for notable or suspicious events. And when an event is found, it basically sends information about the event to one of a number of outputs. Back in December, we added support for Kubernetes audit events to Falco. Traditionally, it's worked with system calls, because that's kind of the heart of what Falco's been doing and all of what Sysdig does. But we added support for Kubernetes audit events back in December. We basically added a little embedded web server into the Falco binary that can be used to post these events to. And then we wrote 30-odd new rules to look for specific use cases. They kind of fell into three different classes. The first one is kind of suspicious activity. This is cases where the rules are pretty opinionated and they're looking for specific notable things or bad things. The second class is just changes to your cluster. So this isn't quite so opinionated, but it is letting you know anytime somebody tries to create something or delete something or modify something. And the final class is if you don't get what you want out of anything else, we do have one rule, which is literally print every audit event we get. You probably don't want to turn that on in production, but it's a good thing for like debugging type stuff. So here's an architectural diagram of Falco, just because you can kind of see the flow of the messages and how it works. Everything in the dashed blue box is the Falco binary itself. It kind of starts with these rules, the Falco rules in the, let's see, my lower right and also your lower right. And the rules get loaded up into a rule engine. And then they just accept events from a variety of sources to see if the events match one of the rules. Traditionally, it works with system calls, so we have this kernel module for system calls. But importantly for Kubernetes audit support, it all comes from this embedded web server. So you enable Kubernetes audit support in your API server, have it post to the webhook. Our web server picks it up, takes to the events, matches it against the rules, and then when an event matches one of the rules, we send it to one of the outputs. So you can send it to like syslog, write it to a log file, post it to a Slack webhook, send an email, make pagers go off if anybody still has a pager. So that kind of stuff. Here's an example of what the Falco rule, an example Falco rule looks like. Again, we're using this use case of a config map with private credentials in it. And we'll just kind of walk through it top to bottom. So there's two kinds of, this is all YAML, there's two kinds of objects here. There's macros and rules. Macros are kind of just used for code reuse purposes and structure and that kind of stuff. So the first macro is called create private credentials. And the condition field is basically a filter a little filter snippet that we're using to match against the events. In this case, we're saying, hey, it's like a logical expression combined with these field names, and then it results in a true or false value. In this case, we're saying ka.rec.configmap.object, which is basically in the request, is there a config map object? And if so, give me that as a string. And we're just looking for AWS access key ID, or S3 access key ID, or password. Obviously, if you put your password in your config map, but you didn't name it password, we won't find it. But if you did that, you're probably not dumb enough to put your password in the config map in the first place. So I'm not worried about those guys. We're worried about the slightly dumber guys. So that's the first macro. The next macro is basically just called config map, and it's saying, is the target resource config maps? Again, for each of these fields, we're extracting that data out of the JSON audit event we already showed you. Okay? And the third macro is called modify. We're just saying, hey, is the verb part of the audit event either create or update or patch? Okay? Now we have a rule. Rules have names. In this case, it's create, modify, config map with private credentials. They have a description, which is nice for output purposes. And then they have the condition, again, where we're filtering against the audit events to see if something matches or doesn't match. And we're just taking all the macros and just putting them together with ands. So it was a config map, and it was a modify action, and when you go look at the contents of the config map, it had something shady in it like a password. When the event matches, we have to decide what string to send to our outputs, and that's controlled by this output property on the object. It's kind of a mix of plain text and these sprintf style fields. Again, the values of these fields come from the audit event itself. We kind of run it through a glorified version of sprintf, and then that's the message we're going to send off to the emails and Slack and so forth. Okay? And then we have like priorities, so you can do some, severity matching and only, really make the pagers go off for the critical stuff, but not the debug stuff. And you can have tags, so you can group rules together. Okay, so what I thought we'd do now is let's kind of jump into some ideas about how to use audit logs, to match some security use cases. And for that, we'll kind of refer to some of the Falco rules for how to do that. Though obviously you can do it just as easily using anything else. Though we love Falco. So the first thing is maybe you just want to know what's going on, right? You're not particularly opinionated to look for bad activity, but you just want to see all the changes that are happening to your cluster. So we have a bunch of rules that look for all that stuff. So Kubernetes deployment created or deleted, service created or deleted, all that kind of stuff. Both the main resources and also like RBAC stuff. So when you create service accounts or roles or role bindings, we'll see all that stuff as well. So this isn't, it's more about tracking changes and giving visibility than looking for specific bad behavior. Okay, so getting a little bit more opinionated, let's say one thing you want to do is you want to just like define what's allowed, like only let certain users do stuff to my cluster, or only let pods run if the image is in a set of images that I say are okay, or only let people run in the production namespace and the dev namespace, but not the super hacker or crypto mining namespace that somebody created that you didn't find out about until 2 months later, when you wonder why your AWS bill is 10 grand, if you're lucky. So we have a bunch of rules that look for that kind of stuff. And each of these rules is basically associated with a list. So along with disallowed K8s user, there's a list of allowed K8s users. And then it's just matching the user against the contents of the list. I know someone told me that all security is just list matching, but yeah, it is in this case, but it's probably some more. Okay, so that's kind of the idea for that one. Now, if you want to get even more opinionated, where you're looking for more specific use cases, we can do like another set of class of rules. So maybe you want to limit what pods can access. You want to say,
keynote doors are now open. Please make
okay, good.
to hall 6.
No, don't leave. You can't go to the keynote. Lock the doors. Okay, so if you want to get a little more opinionated, let's say you want to limit what pods can do. You know, following the principles of least privilege, let's try to explicitly enumerate what your pod really needs to do its job and not give it any more privileges than that. So we have one rule that's create privileged pod that basically just looks for anybody starting a pod where they set the privilege true flag. You know, maybe there's a good case to do it, but generally you at least want to be aware of it and might want to take stronger actions based on that. So that's one rule that we have. Another one is create sensitive mount pod. What that does is we basically look to see what mounts you have for the pod when you create it. And we see if they're mounting paths from the host file system. And then for some paths, we consider them sensitive. So for example, if somebody tried to mount Etsy Shadow from the host into your pod, probably not a great idea. Or if they tried to mount proc, or if they tried to mount the Docker socket, or if they tried to mount Etsy cron tab so they could launch other attacks directly on the host. We have a fun blog post about that in crypto mining. So we have a rule that basically looks for that. We declare some paths on the host to be sensitive, and if somebody creates a pod that mounts any of them, that's when that rule kicks in. Another one is creating a pod with host networking to be true. Generally, if you can get away with it, try to keep the pods in their own network namespace. Maybe you have a good reason for that, but at least it's something you might want to be aware of. And then another one is creating a pod in any of the kube namespaces. So you probably shouldn't be over there. You should be in your own sandbox. So we have a rule for that as well. And then the dual of this class of rules is instead of limiting what pods can access, we can limit access to pods. So even if you were really smart and you made sure that only a couple of pods were running privileged, if you let anybody exec into any pod, somebody can just exec into one of your privileged pods, and now they can do anything that pod can do. So it's a great avenue for privilege escalation, so it's something you want to really be aware of. So we have a rule that basically looks for that. It's saying, hey, somebody's trying to exec into a pod, and we'll let you know about it. We have a bunch of rules devoted to like users and account level stuff. So we have a rule service account created in the kube namespace. So it says exactly that. You're creating a service account and you're in one of the kube namespaces. Probably shouldn't be over there. Another one, system cluster role modified or deleted. If you're doing any action on cluster roles and the name of the role starts with system, that's kind of like a reserved thing for vanilla Kubernetes. Probably shouldn't be doing that, so we'll let you know if somebody tries. These few are about being lazy when you're defining your roles. So when you're defining your roles, you really should be limited to only explicitly enumerate the things you want and don't ask for anything else. Don't give them anything else than what they really need to run. So if you're writing one of these roles and you're new to RBAC and you're like, oh my God, what is all this YAML? But you saw like, oh, there's this cluster admin, and if I do that, I can just do the things I want to do. That's a good idea if you're just learning out, but it's probably not a great idea later because cluster admin can do all kinds of stuff. So probably not a role binding that you want to grant. And so we have a rule for that. When you're defining your role, you might be a little bit lazy, and you might say, you know what, I'm just going to let people do anything to pods. So for the verb, I'll just say star. Or I'll say, you know what, I'm going to let people do crates on, or maybe lists on anything. So I'll explicitly say get, or view or list only, but then for the resources, I'll just put star. So if you do that, probably not a great idea. It'd be much better if you explicitly laid out the things that you needed. And so if you have that, that's what this rule is looking for. It's looking for people where they're trying to wildcard either the resources or the verbs when they're defining their role. Couple easier ones that are more specific. So if somebody tries to create a cluster role that has write privileges, we'll let you know about it. Obviously, there's great great use cases for it, but there might be cases where you at least want to be notified when somebody's doing it. And another one, this is getting back to this idea of privilege escalation in pods. Even if you didn't let anybody actually exec into pods, but you left the RBAC side open, they could just basically create a role that lets them exec into pods, even though you didn't let them, and then they'll be able to exec into pods. So it's kind of like a second order security problem. So if you try to create a role that allows the pod exec privilege, we'll let you know about it. And then a few I couldn't easily categorize, but I still wanted to talk about. We already talked about this one, the creating the config map with the secret stuff in it. There's this one where it's a little bit legacy, but if you create a request and you don't actually have authentication configured properly, you end up being this anonymous user. So we have a rule that says, hey, somebody who is acting as the anonymous user is doing anything, and you're not really supposed to be doing that. And one final one is if you create a service, you have a lot of choices for how to route stuff in the service, and one of them is node port, which is not super great because it opens the port up on every node. So if you try to do that, maybe you could find a better way to do it, and we'll give you a rule that'll let you know if somebody's trying to create services that way. All right, so let's do some demos. Okay, so we got 3 windows here. In the top window, I'm just going to do some cube stuff. In the middle window, I'm basically, I've set up a file-based audit logging, and I'm just going to tail it through the log and kind of watch all of the events go by. And I've set up all of those JQ filters that I talked about earlier to basically look for a bunch of suspicious and notable activity in the audit stream. And in the bottom, I've got a copy of Falco running in the cluster as a daemon set where it's got all of the Kubernetes audit events set up, and we've configured the API server to route events to the Falco service, which is inside the cluster. So the middle window and the bottom window should be pretty much the same. I'm just showing that there's like 2 ways to do it, though we love Falco, and you should all use Falco. Okay, so let's do something easy. We'll just create a simple deployment based on Nginx. So you can see that it showed up in both things. It showed up a little quicker in the audit log based one, mostly because there isn't any batching there. So the it's just reading the file the second it gets written, and it's not waiting to batch up any events and send them to the API server. So it shows up a little bit quicker there, but it shows up easily in both. And you can see it's like, hey, somebody created a deployment, the name is Nginx deployment, and the image. For Falco, we actually add a little bit more information like the user, in this case Minikube, the namespace, where they were doing it, the RBAC decision, and that kind of stuff. And so we'll just go delete that deployment. So we delete it, and you can see it showing up here, both in the JQ log and the Falco log. So we can do the same thing for maybe something like a service. Same thing, showing up here, and same thing when we delete it. So this is like kind of that first class where you're just trying to track the changes, but you're not like particularly opinionated to understand what's going on. Okay? All right, let me check my little cheat sheet here. Okay. So let's do some more stuff related to config maps. Here's a sample config map. This is getting into that config maps with passwords in it. So here's a simple config map. Up here we got the contents of the config map. And look, I'm a dummy. I put my AWS access key in the config map, so not a good idea. So we'll just go create that and kind of see what happens. So when I created the config map, I can say, hey, somebody created config map. with this secret stuff in it, and I'm letting you know about it. With Falco, we also include like the verb, the name of the config map, and the user, and all that kind of stuff. Okay? Okay, so let's do an exec. So we'll create my Nginx deployment again. And what we're going to do is we're just going to exec into this Nginx pod. Once we go, there we go. Okay, so we exec into it, running a shell, and now we have all the powers that you've granted to that Nginx deployment. But because we've noted the pod exec both in JQ and Falco, we'll let you know that somebody tried to do the exec. It's basically going through the API server, and it's just a get on the pod's exec resource. Okay.
You also audit the commands that are now entered in the batch?
We can do that with Falco, but not using the Kubernetes audit events, because those, once you have the exec session open, I'm sorry, the question was, can you see all the commands that the person is now typing now that they exec'd? You can do that if you use the system call based stuff. And we have something that's a little bit like that, though it's pretty false positive prone, so you'd have to be pretty targeted for it. But you could basically look for execs, the exec system call, and then you could see the commands that they're running. Okay, so let's do some stuff with RBAC. So the simple thing is, first, let's just create a Surface account. You can see like, just like all of the resources, when somebody creates a Surface account, we can see that in the audit events as well. All right, so let's do a little bit more interesting stuff. So here's a cluster role and cluster role binding where we've basically gotten lazy about the resources that we have. And we're saying, hey, we'll let somebody do a get, but we won't say what they can get. We'll just say, hey, let them get everything. Not a great idea. So when we try to do that, you can see that both in the JQ-based output and the Falco-based output, because we're looking for the config map, or sorry, for the cluster role, looking at it, seeing that there's a wildcard in there, and we'll let you know about it. Okay? Another one. So let's look at the one where you try to grant permissions to pod exec, even though you weren't able to pod exec before. So here's another cluster role and cluster role binding where we're basically trying to grant ourselves the ability to exec into pods. In this case, the resource is pods exec, and the verb is get. So when we create that, again, Falco's detecting it, and JQ is detecting it, saying, hey, somebody created a cluster role where they're trying to grant the ability to exec into pods, so we'll let you know about it, and then you can decide what to do after that. And the last one, let's say you just want to try to squirrel your bad stuff away in a namespace. So I'm going to create some namespace called secret namespace, put all my bad stuff in there, all my crypto mining and stuff. Well, you do that, we'll detect that too, because number one, we can detect when the namespace got created, and then also if you had this allowed list, not allowed list, we'll check it against the list and let you know it's outside of the list of things that we expected to see. Alrighty, so hopefully you're super psyched about Kubernetes Audit Logs, or hopefully Falco, because we love Falco. So here we got all the links for you. Falco.org is the main site for Falco. We have a public Slack, and there's a Falco channel on there where you can learn more about Falco. We got a bunch of blog posts where we talked about Falco use cases and that kind of stuff. It's all open source, so you can just get the source code on GitHub. We got docs there, and we publish Docker images of all the software, so you can learn more about the images and that kind of stuff. And I think I was supposed to say sched.com. If you love this talk and love Falco, go review the talk there. Is that right? All right, there we go. All right, thanks a lot. I don't know if we have, nope. If we have time for questions, if not, just come up and ask me questions. All right, thanks.